Hello, welcome to the last day of the Chapter 4 notes. Today we're going to be using isosceles and equilateral triangles. So our objective is to use the properties of isosceles and equilateral triangles to calculate missing side and angle measures. Alright, so just a review. What is an isosceles triangle? It is a triangle that has at least two congruent sides. So it could have more, okay, but it has at least two congruent sides. An equilateral triangle is a triangle that has exactly three congruent sides. So now, a thing that confuses kids sometimes, is an isosceles triangle an equilateral triangle? Could be. Is an equilateral triangle an isosceles triangle? Absolutely, every single time, because by definition, an equilateral has at least two congruent sides. Equilateral triangle does have at least two. In fact, it has three. So, it would be an isosceles. All right, so now before we move on, we need to discuss some properties or some names that come with an isosceles triangle. An isosceles triangle has two legs, and the legs are the congruent segments, and then the non-congruent side is called the base. So here, what we have, these two angles are called base angles. And the top one is called the vertex angle. So it's an important one, the vertex angle. That's the one that is not a base angle. It's not attached to the bases. So that brings us to our first theorem here. It says if two sides of a triangle are congruent, then the two angles opposite of those sides are also congruent. So what does that mean for us? Well, it means that if we have an isosceles triangle and it has those sides that are congruent, automatically we would know that those opposite across from those sides, those angles are also congruent. So in an isosceles triangle, the base angles are always going to be congruent to one another. All right, example 1 over here. If the length of HG is equal to the length of HK, I'm going to mark that in my picture by doing my tick marks, then what is congruent to what? Then we would know that angle G is congruent to angle K because it's the two angles that are across from those two congruent sides. All right, the second one says if angle KHJ, so this angle up here, and then we got cut off, so we have to write what this next one is, and it should say angle KJH. All right, so if we know that angle KHJ, the one I marked in green, is congruent to KJH, this one, then I would know that segment HK is congruent to segment KJ. Because the converse is also true. If you know that two angles of a triangle are congruent, then automatically the sides opposite those angles are also congruent. All right, so this part we already know. If a triangle is equilateral, then it is also equiangular, meaning all of its angles are the same measures. All right, example 2 here says, find the angle measures of equilateral triangle PHS. Uh-oh, there's no triangle drawn, so how would I find that? Well, it's quite simple. All of the angles in an equilateral triangle are congruent, so to get each measure, you would do 180 divided by 3, and I could draw the triangle if I want, PHS. I can name the angles X, X, X. So then I would know that X plus X plus X equals 180. 3X would equal 180. So as I was saying over there, divide by 3, and you get that each angle measure is equal to 60 degrees. Example 3 here says, find the value of X in the figure below. Now, kids are constantly adding the three sides of a triangle and setting it equal to 180. That makes no sense. If you think that makes sense, that means any triangle you have, a teeny tiny one in your hand or a gigantic one in a cornfield, if you drew a triangle, that if you add up all the sides, it equals 180. 180 what? Feet, centimeters, inches? We don't know. That is not true. The sides of a triangle don't add up to a certain number the way that the angles do. So don't ever think that. So the first thing we have to do here is look and see what kind of triangle we have, and then figure out, do we have any congruent sides? Well, I notice that I have two angles here that are congruent, this one and this one, which automatically makes the sides across from them congruent. Okay, so that means this side and that side. Across from those angles, those sides are congruent. So we're gonna go ahead and set up an equation. 3x plus 9 equals 24. So 3x is gonna equal 15, x equals 5. Now, what about that bottom side? Or in this case, it would be the base, that 18. Does that bother us? No, we don't care about that. It's an isosceles triangle. It doesn't mean that all three sides have to be congruent. Okay, so that brings us to example number 4. We're gonna find the values of x and y in the diagram. All right, so what I see here is two different triangles, and I do see that one of them is equilateral, this one over here, more on the right side, and the one on the left is isosceles. So again, I could tell that because of the side markings. So hopefully you see right away that the measure of angle x has to be 60 degrees because it's equilateral, and in an equilateral triangle, all the angles are 60 degrees. All right, so what's nice about an isosceles triangle, just as a side note over here, if you have an isosceles, all you need to know is one angle, and you could find every single angle in that triangle. Let me draw that a little bit bigger. But if I was to tell you that this is isosceles, and this angle, let's say here, is 20 degrees. Well, that's going to let me find all the angles, because if this one's 20, then this one has to be 20, because they're base angles, and base angles are congruent. And so then the vertex angle would be what's left over. So 20 plus 20 is 40. I know that the angles have to add up to 180, so this would be 140. Okay, so that's if you're given a base angle. Now, for example, if I was given the vertex angle, let's say the vertex angle in this problem is 80. All right, well, I know that these two are congruent. I could call them x, let's say, or just think of them in terms of them both being x degrees. So I would have x plus 80 equals 180. So I know that these two x's have to share 100 degrees is left over for them, so they would each be 50. All right, so how does that help me with example 4? Going back to example 4 here. Well, if this is an equilateral triangle, then all of these angles are 60, right? All three angles are 60. This angle here is marked as a 90-degree angle, so I know that the base angle here in this triangle, this one's 30. If that angle's 30, then this angle's 30. So 30 plus 30 plus y has to equal 180 degrees. So I get 60 plus y equals 180, so y would equal 20 degrees. Okay, x is 60, y is 20. Anytime I see a problem like number 5, I do not worry at all at first about what angles I'm supposed to find. I just start finding any angles that I possibly can. So in this picture, I see here that I have two angle measures given. So anytime you have this kind of X formation like here, it doesn't matter if it's part of a triangle, it doesn't matter if it's parallel lines, nothing matters except for the fact that you could find all the angles if you're just given one. So I know that 3 and 105 are a linear pair. They have to add up to 180. 105 and angle 4 are a linear pair, so they have to add up to 180. So I know then that angle 3 is 75 degrees and 4 is 75 degrees. All right, so notice here I have an isosceles triangle, and as I said earlier, all you need is one angle, and in isosceles you could find them all. So if these are my congruent sides, these are going to be my congruent angles, so angle 1 is 75. Angle 2, how am I going to find it? Well, I'm going to add 75 plus 75. I get 150. Leftover is for angle 2 to have as its measure. Right, looking over here at this bottom triangle, at this point, it doesn't say it's isosceles, it doesn't say anything, I only have one angle. I can't find angle 5 or 6 at this point. So what I'm going to do is move on to this triangle in this area and see what I have. If this angle is 42, this angle is 42. Vertical angles are congruent. Then I see that I have a right triangle, so I have two angles. I could find the missing one, or if you remember from earlier in the chapter, I said that if you remember the two acute angles in any right triangle are always going to be complementary. They're going to add up to 90. So angle 7 is 48 degrees, okay? Because 48 plus 42 is 90. If 7 is 48, then 6 is 48. And then I could find angle 5 because 75 plus 48 plus the measure of angle 5 is going to equal 180. All right, so I get 123 plus the measure of angle 5 is equal to 180. Subtract 123 from 80 and you should get 57 degrees for angle 5. So just go ahead and write all those angle measures in. We found angle 1 is 75, 2 is 30, 3 was also 75, angle 4 is 75, 5 is 57, 6 is 48, 7 is 48, and 8 was 42. All right, moving right along, let's do number 6 here. It says find the perimeter for each of the following. So, as I said earlier, the sides of a triangle will never add up to a specific number like the angles do. Angles add up to 180. The sides add up to any possible number, can't be negative. So perimeter, remember, is to add up all the sides. So if I was to add up all the sides for this first one, I would have nothing to equal it to, right? So I would have something like 2x minus 1 plus x plus 4 plus 7 equals, and then I don't know what the perimeter is. If I knew what the perimeter is, then I could set it equal, solve for x, no problem. This, however, I don't know the perimeter, so I can't do that. So instead, I have to notice what kind of triangle am I given, for example, 6, the first one, and I notice that because of these two angles, it is an isosceles triangle, which means these two sides across from those angles are congruent. So 2x minus 1 is equal to x plus 4. All right, those two sides are equal. I'm going to solve for x. I'm going to subtract x from both sides, giving me x minus 1 equals 4. Add 1 to both sides, and x is going to equal 5. So they did not ask me to find x, but I did need to find x in order to find the perimeter. I know that the base of this triangle is 7, so now I have to find the two legs by plugging in x is equal to 5. So this leg would be 9, because 5 plus 4 is 9. If I plug 5 in here, I get 2 times 5, which is 10, minus 1 is 9. It should be no surprise that those two sides are congruent. It is an isosceles triangle. I already said in the beginning those two sides should be congruent. So the perimeter is going to be 7 plus 9 plus 9, so 25, and I don't know what units are on there. Oh no, it is feet. Okay, so 25 feet. Right, this next triangle here that I'm trying to find the perimeter of, notice right away that it is an equilateral. How do I know that? Because these three angles are equal to each other, so that makes it an equilateral triangle. And again, if I'm looking for the perimeter, I add up all the sides. I don't know what they equal because I don't know what x is. So it's not like the sides add up to some certain number. So I just set any two sides equal to each other. Doesn't matter which two because it is an equilateral triangle. So I chose these two because it's the smallest numbers for x. Add 1 to both sides. So x plus 14 is going to equal 3x. Subtract x from both sides. 14 is going to equal 2x. Divide by 2, we get x equals 7. But again, they wanted me to find the perimeter. So if I plug in 7, I'll get 20 here, 7 plus 13. If I plug in 7 on the bottom, I get 3 times 7, which is 21 minus 1. This is 20. And then over here, if I plug in 7, 6 times 7 is 42, minus 22 is 20. Again, the fact that the three sides are equal should be no surprise because it is an equilateral triangle. And so the perimeter is 60 feet. not squared, area would be squared. Example 7 here, we want to find the values of x and y. Notice this time our variables are inside the angles. So your initial instinct may be to add up all three angles. So 3x minus 11 plus 2x plus 11 plus 2y, and the angles do add up to 180. However, I would hope that you would see right away that you run into a problem because you have an equation that has two different variables and you only have one equation. So therefore we have to go a different path. Now remember that this section is about equilateral and isosceles triangles, so you're probably going to have to use that to figure these out. So to get x, I notice because it's isosceles, this angle and that angle are congruent. So I'm going to set 3x minus 11 equal to 2x plus 11. I'm going to subtract 2x from both sides, giving me x minus 11 equals 2x. No, just kidding. It's going to equal just 11. Add 11 to both sides, I get x is equal to 22. All right, but I still have to find y. So if I have x, I could find the base angles of this isosceles triangle by plugging in. So if I plugged in here, 2 times 22 is 44 plus 11 gives me 55. If that angle's 55, then this one's 55, and I could double check by plugging in, which means the sum of these two angles is 110 degrees, right? If I do 55 plus 55, I get 110. So then, if those two angles took up 110 degrees, a full triangle's angles, all three add up to 180. That means 2y has to equal what remains, and that would be 70 degrees. Okay, 2y is equal to 70 degrees. Divide by 2, y is going to equal 35. All right, last problem we're going to do together. We're going to take this triangle and we're going to solve for x and y. So notice that 3y is on the outside. We haven't seen this for a few sections. That is an exterior angle that's going to equal the sum of these two angles. So if I was to set that up, I get 3y equals 4x plus 10 plus this bottom angle. Now I know what that bottom angle's expression is, but I'm not going to use that right now. Instead, because I'm going to have an equation with x's and y's. Instead, what I'm going to do is add up all three of the equations of the triangle. So x minus 2 plus 4x plus 10 plus this bottom angle is the one that I don't know. Again, remember this section is about isosceles and equilateral triangles, so I'm probably going to have to use that to figure this out. And I notice that it's an isosceles triangle. I see that because these two sides are congruent. So that means the base angles are congruent. So this missing angle here with the question mark is the same as the other base angle, so x minus 2. 4x plus 10 is what's called the vertex angle. So I'm going to add another x minus 2 here, and that whole thing adds up to 180. All three angles of a triangle have to add up to 180. All right, let's clean up this whole left side. I have x plus 4x plus x. That gives me 6x. I have a negative 2 plus 10 minus 2 is going to be plus 6, and it equals 180. Subtract 6 from both sides, you get 6x equals 174. X is going to equal 29, I believe, is the value for x. All right, how is that going to help me find y? Well, as I said before, we could use, actually, I would use that these two are a linear pair. They have to add up to 180. So 3y plus x minus 2, but we know x is 29 minus 2. That has to add up to 180. So 3y plus 27 equals 180. 3y is going to equal, if I subtract 27, I get 153. Y is going to equal 51. Okay, let's see the other problems on the next page, see what we're going to do together. This last page you're going to do in class tomorrow with your teachers, because especially this bottom example 3, notice that the angles and segments did get cut off, which I apologize for, but your teachers will tell you what those are tomorrow. All right, thank you so much for watching. Have a great day.